Both scales read 1 metric ton. The iron block is compact. The wooden one is almost a piece of furniture. Which is heavier? If 1 metric ton means exactly 1,000 kilograms of mass, neither. End of riddle. But here, only the scale readings are fixed, and both readings were taken in air. With that setup, the wooden block can contain about 2¼ kilograms more mass than the iron. The room is helping it cheat. A scale does not sense mass directly. It senses how hard the object presses, then uses its calibration to report a mass value. Gravity pulls the load down, the platform pushes up, and the scale records how much support it must provide. But our picture is missing something. The scale is not operating in empty space. It is sitting under an atmosphere. For the reference conditions we'll use, 1 cubic meter of air has a mass of about 1.2 kilograms. Pressure is slightly higher at the bottom of the object than at the top. Add up all those pressure pushes, and a small upward force remains. That force is buoyancy. It equals the weight of the fluid the object displaces. And air is a fluid. Archimedes does not stop working at the waterline. Displace 1 cubic meter of air under those conditions, and you get an upward force equal to the weight of a 1.2 kilogram mass. That is unimpressive for a coffee mug. For a load near a metric ton, it begins to matter. The scale only has to support what the air does not. So the force reaching the scale is the object's gravitational force minus the buoyant force. 1 downward arrow, 1 smaller upward arrow. The scale gets the difference. Now give the two loads the same true mass, exactly 1,000 kilograms each. For a clean example, use sealed blocks. Choose wood with a density of 500 kilograms per cubic meter. 1 metric ton occupies about 2 cubic meters. Pure iron, at about 7,874 kilograms per cubic meter, needs only 0.127 cubic meters. The wooden block displaces about 2.4 kilograms of air. The iron block displaces about 0.15 kilograms. So the difference in buoyant force is the weight of roughly a 2.25 kilogram mass. On the same scale, the wood reads a little lighter. Air's generosity is set by volume. Rustic charm earns no bonus. Now return to the opening shot. We did not start with equal masses. We started with equal readings. To make the bulky wooden load press just as hard as the iron, you must add mass to the wood until its extra gravitational pull cancels its extra buoyant lift. Metrologists call the standardized result conventional mass. Its reference conditions use air at 1.2 kilograms per cubic meter and reference weights with a density of 8,000 kilograms per cubic meter. Under that convention, our wooden block needs about 2.25 kilograms more true mass than the iron block to produce the same 1,000 kilogram result. The scale readings matched, the masses did not. Imagine repeating the force measurements in a vacuum, with the instruments properly set for that environment. The blue air arrows disappear. Neither object gains matter, and gravity has not been turned up. Both loads simply lose the support that the atmosphere had been providing. The wooden load changes more because it had displaced more air. Starting from equal readings in air, the wood now presses harder than the iron by the weight of about a 2.25 kilogram mass. The vacuum did not add a splinter, it removed an accomplice. Before declaring wood the winner, keep the condition in view. A metric ton is exactly 1,000 kilograms, whatever it is made of. If both masses are properly established, they are equal. Real scales are calibrated, and precision labs correct for air buoyancy. Temperature, pressure, and humidity change air density, while wood density changes with species and moisture. Volume also needs care. Air that can flow through an open gap has not been displaced, so a loose lumber stack is not a sealed 2 cubic meter block. On a kitchen scale, this effect is usually buried under larger errors. For a low-density load near a metric ton, It can reach kilograms. So, is a metric ton of wood heavier than a metric ton of iron? If metric ton means true mass, no. 1,000 kilograms is 1,000 kilograms. But if both loads were adjusted until the same scale reported 1 metric ton for each in air, then yes, the wooden load can contain a little more mass. The extra mass was there all along. Air had simply been helping to hold the wooden load up. Next time, why a smoke alarm stays put while its chirp seems to jump from room to room.